Hello, I'd like to welcome everyone to Arup's first event in our 3 days Digital Horizon series, exploring how digital, data, and AI can help us achieve meaningful climate impact. The events will be covering how digital is helping deliver a net zero climate and nature positive world, how digital twins and asset management are accelerating decarbonisation, and today's focus, how is AI being used for positive impact in the built environment? My name is Caro Ames, and I'm the UK IMEA Data Science Strategy Lead within Arup's Digital Services portfolio, and I will be leading today's event. Today's session is incredibly important to me. I left tech to come to Arup with the sole focus of supporting organisations across the built and natural environments and using data and AI to improve business, societal, and environmental outcomes. The sectors that we work in are undergoing significant change as we look to deliver resilient net zero infrastructure across the geographies that we work in. There is a need to do more with less, do things that we have never done before, and provide accountable, robust decision making across everything that we do. For me, the role that data and AI play in this transformation is critical. I see opportunity everywhere that I look, from operating more efficiently through the use of Gen AI and LLM capability, to the use of generative design algorithms to design flood defences, or optimizing and operating our energy system in the face of intermittent and distributed generation. But there are also challenges that we have to overcome in order to realise that opportunity. And now we come to today. So up front, I want to say a huge thank you to everyone for making the time to attend, particularly given the global nature of the call, and to our speakers who will be hearing from today. Today's session will cover a welcome from Arup's Global Head of Digital Services, Will Cavendish, a keynote speech from Lewis Richards, Chief Sustainability Officer for Microsoft UK, followed by a panel discussion chaired by Sanka, Arup's Digital Services Leader for East Asia, and contributors covering Lewis Richards, Jean Innes, the CEO of the Alan Turing Institute, the UK's National Institute for Data Science and AI, Benson Lee, Senior Environmental Protection Officer at Hong Kong's Environmental Protection Department, and Magnus Cormack, who leads AI and analytics at National Grid ESO, who are responsible for operating the UK's energy system and are shortly to become the National Energy System Operator. It is my hope that today's session will spark a discussion that we can start in Q&A and take forwards into our teams, organisations and sectors to drive forwards the use of this transformational technology in the work that we deliver. I will now hand over to Will for his introduction.
Welcome to Arup's global webinar series, Digital Horizons. It's fantastic to bring people together both on our panel and online to explore a topic I know that many of us care deeply about. How can we use digital to achieve meaningful impact in shaping a better future for the built environment? Many people here will be confronting the same generational challenge we're facing here at Arup. How can we meet the human needs of the roughly 10 billion people that will soon be living on our planet, while at the same time reducing significantly the huge and detrimental environmental footprint of our sector? Through this 3-day webinar series, we want to explore how digital, data, technology and AI can support us in meeting this challenge. Part of this is about providing real-world, tangible examples of where we're already making progress to inspire and give a legitimate sense of hope, but also to explore some of the barriers to getting the most out of these solutions and figure out how we can all go further, faster. This is especially relevant when it comes to AI, the focus of today's session. It's a topic that's exploded in the public's consciousness after the launch of ChatGPT 2 years ago and has dominated media and conference headlines since. But much of that debate has felt frothy and unconnected to a more honest and impactful conversation about what AI can and cannot do in the built environment world we all operate in. So for example, at Arup, for a while now, we've been all in on developing real-world AI that can bring tangible benefits to the work we do in cities, in infrastructure, in property, energy, nature and beyond. And we're doing that using a wide range of AI systems, not just the large language models that have been so prominent recently. For example, we're already using machine learning and large-scale satellite data to design city infrastructure and investments that benefit citizens with lower carbon and greater nature, such as a major program of urban gardens in Mexico City, or planning an urban forest surrounding Tirana, or more broadly tackling urban flooding and inundation by using nature-based solutions for water infrastructure in multiple cities and districts around the world. And completely different areas, such as using the power of large-scale data and AI to develop a system for predicting and better managing traffic incidents for a major transport agency, or harnessing the power of generative algorithms to design buildings and campuses that have significantly lower embodied carbon footprints. Of course, many others are doing similar things. So as we as a sector all continue to make the most of the AI opportunity, it's crucial we address both the opportunities and the risks. For example, many companies, Arup included, have experienced how advanced digital technologies can be misused, with deepfake scams targeting businesses. As we learn from this, we must consider how we develop AI responsibly, ensuring it is safe, ethical, and aligned with our values. This requires us to ask key questions. How do we prevent bias in AI models? How do we ensure transparency and accountability in AI decision-making? How do we pursue an ethic of safety as well as an ethic of use? But we also need to address some of the practical barriers, the poor quality of data, the shortage of skills, the fragmentation of our sector, the conservatism of some of our processes and ways of working that can stymie the positive potential of AI to meet both the sector and wider sustainability goals. So today we have a keynote speaker and a panel drawn from around the world and with a wide range of sector expertise to help us tackle these problems. And we hope you fully enjoy the session.
A big thanks to Will for the introduction and providing such thoughtful context and insight into some of the work that Arup has been delivering globally in this space. For the next part of the session, I would like to introduce Lewis Richards, Chief Sustainability Officer for Microsoft UK, who will be leading our keynote speech and providing his perspective on today's topic. Thank you.
Thanks, Karen. Yeah, pleasure to be here this morning. I was going to talk a little bit this morning about sort of three aspects, really. Talk about a little bit about the impact of AI in digital on us as humans, as individuals, how that impacts our kind of well-being, our work and life. In the context of the digital world that surrounds us as individuals, but also how we interact with the built environment. Talk a little bit about the skills and responsibilities as well that we think are probably going to be more relevant for humans to take some control over. I was going to then talk a little bit about, or bring to life an example of one of our campuses, and how we drive sustainability into our campuses, especially in Redmond. And talk a little bit about that combination of technology in terms of how do you use data with AI, with digital twins, with the built environment, just to bring that to life a little bit in terms of how that balance of environmental sustainability and how you can measure and monitor and see what goes on. Talk a little bit about our goals as well, just from a scene setting point of view, a little bit of context about what Microsoft is trying to do from a sustainability perspective. And then I thought I'd expand on that a little bit then and give some examples of specific uses of AI in terms of populations in the context of populations within cities and beyond as well. So I was going to talk a little bit about our AI for health initiative, so specific use cases of using AI, and particularly generative AI, in terms of helping promote general health and well-being, and talk a little bit about that kind of how do we see that the kind of things that we're making available, or we're working with partners and customers to and making open source and free for people to use at a kind of a macro level. How do we look at it from a climate change impact point of view? How does that affect people in the built environment? So that's kind of what I'm going to aim to go through over the next sort of 12, 13 minutes or so. We'll just move on with the slide in. So very briefly, Microsoft sustainability goals. We've made some ambitious pledges a few years ago. We plan to be carbon negative by 2030 in our direct operations. We plan to be water positive by 2030 in terms of how much water we use in our direct ops as well. Heavy focus on zero waste by 2030, and that's particularly evident and important in our data center complexes as well. We have this concept of circularity centers. And I'm going to touch a little bit about the built environment there in terms of how we help people use our technology to sort of help themselves within their own built environment. But obviously, we have a lot of capital build as well because we build data centers, and our aim is to make those as efficient and as effective and as less impact on nature as possible, really. So we do a lot of work around biomimicry and things like this now, and reducing the amount of power and water that we use as well. And within the data centers, the stuff that goes into those data centers, there's a concept of circularity centers, and there's huge amounts of innovation going on in terms of the components that go inside the built environment as well. And then right down to the software level as well. So we use the AI that we make available for customers to use. We use ourselves, and we use that in terms of power, energy efficiency, water efficiency, that kind of stuff. And even around to the point about helping our humans interact and working in around that built environment. And finally, as well, part of that ambition then is around protecting more land than we use as well. So we do a lot of work around things like we do with water replenishment projects in water stress basins. We do a lot of work around biodiversity and sort of making sure that the natural world is protected as much as possible. So we try to take this holistic, like a wraparound approach for everything that we do from our sustainability goals. And then that translates into then helping customers to use our platforms in a safe way. But the big thing at the moment, I suppose, is AI is the buzzword of the moment, I suppose, and it's getting. I think when we say AI at the moment, I think very much lots of people we're really talking about generative AI. AI is a concept, as you'll all be aware, has been around since the 60s, is in terms of the different models and machine learning, neural networks, deep learning, that kind of stuff. We're just at this point in time now where generative AI is the new thing that we're doing. Interesting though from a human point of view, because I think it is fundamentally changing our relationship with the kind of hard endpoints of technology as well. And what I mean by that, and it's a very key one for me with humans and the built environment as well, because it's that digital interface between us as the biological squishy bits and the built environment is technically at the moment probably more and more likely going to be our mobile devices, our phones in our pockets. And up until now, we've been the master and commander of those devices in terms of when we interact with data and AI in buildings. It's very much on a conscious choice. I think humans, we choose to open an application, we choose to find a desk, we choose to use wayfinding, we choose to book coffees, that kind of thing. But in the world of AI, especially now in the concept of increasingly we're going to start to see agent AIs, which is AIs working on behalf of you to go off and talk to other AIs and other data sources. Humans are at risk of being further removed from an understanding of where the data and where the systems are in which they operate. So one of the things that we're really keen to talk to people about really is this idea of responsible AI. And we have these 6 principles that we use around AI systems that have to be, it's around fairness, around reliability and safety, privacy and security, inclusiveness, transparency and accountability. And this translates into kind of how we think about building systems and how we think about making systems available for people to use and apply to the built environment and the world. But also it's a really key one for individuals, for humans as well. So each of us as a human in this world, the Pandora's box has been opened. It's probably not going to close again now in terms of the actual the generative AI. So we've got to take responsibility, or more responsibility, to kind of get to grips with the world around us. And it's the digital world that you're not biologically equipped to see. And part of the challenge for us as technologists is helping the squishy biological bits to understand and interact with the data and the AI in the world that we live in, really, so that it becomes a beneficial environment for us, and it helps us to be more well, to live better lives, this kind of stuff, and it doesn't become a drain. And that balance has to be struck then in terms of what the environmental cost is for that interaction between the pivot points between construction, the built environment, humans, energy, power, and water. If I look at this is a picture of our part of our Redmond campus in Washington State as well. And this is our geothermal energy center. So this building's a good example of an older campus. It's been retrofitted and it's been modernized, really, and it's got a combination of technologies then that we've applied ourselves to use. So we've deployed over 50,000 sensors in roughly 100 buildings in this region, and we capture the data from those sensors and we identify, just like everybody else does, issues and inefficiencies. And it's not just our technology as well. We interact with Econics for some of the building management systems, that kind of stuff as well. What we've done though is we've tried to reduce. We've been reducing we're the first kind of large corporate user of like the embodied carbon calculators, and we've used that tool to kind of reduce to use lower carbon building materials. One of the things that we have is we have $1 billion climate innovation fund that we've had for a number of years. We're using that to kind of kickstart marketplaces for materials and new material science and companies so that we can actually start to use these kind of physical products ourselves in the environments. To date, I think as of May, I think we'd spent something like $768 million of the $1 billion climate fund, I think, has been allocated so far. But these are things like we invested in sort of net zero carbon steel production. We're invested in algal-based concrete, that kind of stuff. And it's the combination, I think, of using those tools and using technology and data has allowed us to we found large reductions in, I think we say something like 30% of our embodied carbon on campus at the moment, just through the reduction of ceiling tiles, carpet, concrete, steel. And then using it alongside software so that we're tracking sort of energy and fuel use as well, that kind of stuff. And then the geothermal capability obviously allows us to use geowells so that we're able to use, it reduces our energy consumption by sort of typically 50%, I think, compared to a typical utility plant in terms of what we're doing as well. And the system is then using, and the system uses, or the buildings use the combination, as you imagine. We use water, we have water runoff systems, we have water capture, that kind of stuff that we use in. And I think the stats were something like, I think we were something like nearly 6 million gallons annually of water saved. I think it is just from the buildings themselves. The thing that we find interesting about it, though, and I'm sure the same with you guys, is that connecting up sensors and data isn't really the hard point. It's making sense of the noise that comes into that from faults that come through, and you can very quickly become overwhelmed with IoT data and sensor data that comes into the systems, and you have the same problem around nomenclature, naming conventions, building, all that kind of stuff that if you're in the built environment, you're all very, very aware of. One of the things that we're starting to see doing here, though, is that addition of AI and machine learning and generative AI capabilities on top of those data sets as well. So one of the things that we're doing or we're experimenting with in the building is basically, how do you teach a machine to think like a technician? So we basically have paired up technicians that we've had on site for years who are able to interpret faults and signals that come in from the sensors, and then try and translate that technician process into a machine learning model so it can mimic behaviors of the technicians. And having that kind of being able then to sort of model and refine those models and apply them then to large sets of data has improved our ability to make sense of the telemetry that comes in from these kind of environments as well. And I think we're starting to see more and more of that. And I think as you see the difference between new builds versus retrofit technology builds, this kind of stuff, this idea of making sense of the noise, and this is kind of where the opportunity is for AI to sit on top of data sets and sort of to interpret and make it easier for us as humans to make the right decisions at the right time. I think that's the really interesting bit of it as well. So moving on and think about the specific use cases of AI as well, then in terms of groups of people from the population and that kind of stuff, and how do you see that, or how do we see that at a slightly more macro level as well? We've got something called the AI for Health research program. So Microsoft Research is like a $19 billion part of the business, and it has a number of strands. We have our AI for Good lab, we have our AI for Health lab, we have a metagenomics pipeline one. We do stuff around, we have something called Microsoft Premonition that we use for doing things like biomimicry and invertebrate and animal tracking, this kind of stuff. So we take the concepts of using data and AI on the platform and make them available for people to kind of use in terms of plenary research, that kind of stuff. And you may have heard of our planetary computer as well, which is huge sort of data sets of data that's available for people to kind of use to come up with new products and services to help with the effects and mitigate the effects of climate change. AI for Health, interesting as an area of research. So what we do there is we provide help and grants around the idea of population health. So how do you integrate data from health sectors and utilize AI and visualization techniques specifically to individuals and groups of people? It's the application of AI and data to image and analytics. And you've probably seen lots and lots of case studies and stories about the benefits of this around sort of radiology and x-rays and this kind of stuff, and disease prevention, that kind of, or spotting diseases, that kind of stuff. And then basically speeding up genomics and genomic research, basically. So this is kind of looking at how do you predict disease risks and stuff like that. And those capabilities then manifest themselves at different levels. This is a really good example of something that came out of AI for Good lab, and it's to do with smoking, basically, in and around environments and stuff like that. And smoking is still a massive problem. We still have something like, I think it's something like over 1 billion active tobacco users in a year, and about 8 million people a year die from it. And what we're finding in the US is that the desire to quit is evident. At least 70% of smokers say they want to quit, but then it's the link between the human and the human clinician is the challenge. And most of those people, there's less than 10% give up completely. So it's a very hard thing to quit in terms of this. And the clinical intervention piece is the is the key, where AI is practically providing examples for us at the moment as well. So this is QuickBot, which is basically developed with us with the Fred Hutch Cancer Center and a psychologist called Jonathan Bricker, basically. And it's a free smartphone app that can use, but it combines basically an AI clinician that uses generative AI and large language models alongside structured Q&A type approaches to basically help people to quit smoking or smoking cessation. It has other smoking cessation techniques inside it as well. And but this app has had more of it's got a 48% success rate after 3 months from those who signed up using it, which is a huge improvement of the typical sort of 10% success rate that you're seeing. And I like this because it's a practical example of using AI where humans can understand that they are talking to a machine. And it's very, very clear that you're talking to a machine and you're not talking to a human clinician. But this idea of this combination of using technology we have in our pockets with psychology, with Q&A and structure, and this ability to mimic a clinician so the human has the feeling, the experience of talking to a human is becoming very, very beneficial as well. At a larger scale, I'll move on a bit quickly, larger scale then, we've partnered up with Novartis and we have this is AI for healthy cities then. So going from that individual to a macro level. And the conditions in which we live are probably more of a determinant in terms of how healthy we are versus than the healthcare you receive as well. So the AI for Healthy Cities initiative in Novartis is basically deployed in New York, Singapore, Helsinki, Basel and Lisbon at the moment. And this is a picture from New York at the moment. And what they're using there is putting together high groups of data sets at a high level, basically, and trying to predict cardiovascular disease and trying to determine from within the macro built environment the health of populations from poorer areas to more wealthy areas, this kind of stuff as well, and looking at these disparities in terms of data. And that takes in data on mental health conditions, depression, stress, anxiety, substance abuse, social needs. It's linked to the hospital EHR systems to understand concerns around paying bills, housing conditions, that kind of stuff as well. And AI here is helping to identify those determinants of health and understand that characterize populations in a macro environment within the kind of macro city built environment as well. And this helps us with city planners and macro level digital twins to actually look at public planning and thinking about how we design cities for the future so that the actual general populace, people don't get left behind, and the use of AI or the impact of AI is equitable for all and that kind of stuff. And I think that's one of the areas in which we're really, really interested in, is this idea of humans individually becoming more responsible for thinking about our place in the world and how we interact with data and digital around the world and how we particularly choose to understand and use AI. And then the responsibility of maybe employers or governments, local governments and things like that, to think about policy and think about the actual, the environments in which we live, from built materials right the way through to the data and the services that we consume as citizens. And AI is going to be a useful tool to help us do these things, providing we understand the guardrails and we understand how to use it effectively and efficiently. And finally, because I'm running out of time, we're trying to just at a really macro level, what's beyond that city scale type of thing as well. I think we all know that we're not doing as a planet, as a species, as well as we could do. So as we look beyond that and we look at mitigating the onset of impacts of climate change, then there's things like this as well. So you're starting to see the creation of these. This is from Microsoft Research as well. This is something that we made available at the start of September as well. It's called Project Aurora. And it's the first large-scale foundation model of the atmosphere that we're giving away for science to use again. So this allows people to take that foundation model and just fine-tune it, so they can actually start to look at that, the impact of those extreme weather events, that climate impact change. And we're already starting to see, like in the UK where I am, with insurance companies picking this up as well. So they start to use this combination of using large data sets with population health, with large scale models of atmospheric weather conditions to impact and predict how the world will respond to the change that we're inevitably going to see. And it's that balance to be struck is kind of where we're most interested in doing that. And our aim is to provide that service, those platforms, those capabilities in the most efficient and effective ways that we can, from our responsibility to the built environment in terms of our power, water, and our effective use of built materials, and then to help customers to understand that they can use that in an effective and responsible way at the same time. And I think I'm about 2 minutes overdone there, so I'm going to stop talking now and hand back to Cara. There we go.
Thank you, Lewis, for taking such a holistic and human-led approach on the topic, as well as providing such a breadth of examples. I think we often focus too much on AI as a technology and not enough on how we need to be and also will be interacting with it in the future. We will now move on to the panel discussion, which will cover the current uses, opportunities, and challenges of AI in the built environment. And before I hand over to Sankar, Arup's Digital Services Lead for East Asia, who will be chairing the panel, I'd like to reintroduce our panelists for anyone who arrived slightly later. So we will be having Lewis, Chief Sustainability Officer for Microsoft UK, who you just heard from. Jean Innes, the CEO of the Alan Turing Institute, the UK's National Institute for Data Science and AI. Benson Lee, Senior Environmental Protection Officer at Hong Kong's Environmental Protection Department. And Magnus Cormack, who leads AI and analytics at National Grid ESO, who are responsible for operating the UK's energy system and who are shortly to become the National Energy System Operator, NESO. Thank you, and over to you, Sankar.
Thank you, Carol. Ni hao, good morning and hello. Wherever you are, good afternoon, good evening, and thank you for joining our first session of the Digital Horizons 2.0. I'm Shankar, your moderator for this session, and I'm hosting you from Asia's World City, Hong Kong. And first, I would like to start with a disclaimer. The positive impact here doesn't mean anything on Wall Street. We are not going to give you any advice on NVIDIA stocks or Microsoft stocks. We are here to talk about the sustainable impact of AI. So with that, I believe we all have the right audience in the right session. And today we have our experts from 2 different continents, but also from very diverse, from public sector, from private sector, and also research organization. So I'm not going to take much time here. I have Benson Lee with me from Hong Kong and the rest of the panelists here on virtual session with me. Right, the first question, Jean from Alan Turing Institute, it's over to you. I try to Google AI and always I get ChatGPT. It seems like over the last 2 years or 3 years, ChatGPT has become the name of AI. So could you please start with a simplistic explanation about where AI and Gen AI or ChatGPT is coming along?
Thank you, Sankar. Pleasure to be here at this very interesting session. I think the first place to start to hold on to is the simplest, most user-friendly definition of AI, which is getting machines to do tasks which to date only humans have been capable of doing. That definition takes us back to the Turing test, which was proposed by a British mathematician, Alan Turing, and computer scientist, Alan Turing, back in the 50s. And it talks about things like tasks such as vision, winning chess games, human-level speech, and human-level understanding. Now, the incredibly interesting thing about the moment we're living through is that the Turing test, as posed by Alan Turing in the 1950s, has, I think pretty much all experts would agree, been passed. And that's really the excitement of the large language models, the ChatGPT that other colleagues have referred to. Just trying to sort of maybe dissect this a little bit, as Sankar indicated. AI has sort of originated in the 50s, has been going through waves of development. And as Lewis referred to, the current excitement is a mix of genuinely astonishing technical work and a lot of hype. And I'm just going to say a few more remarks to just trying to set the scene. The broad capabilities of large language models such as ChatGPT are genuinely impressive and surprising to experts in the field. It's the broad applicability of them that's very exciting and very interesting, but they're not magic. So people with technical backgrounds understand where they came from, and they've been fueled by the access to very large data sets, which the internet has brought, and to access to large-scale compute. But the thing that really took it to the next level was the OpenAI decision to release it to the general public. And so all of us could play with it and sort of get a sense that for the first time, rather than a sort of quite annoying chatbot, we were interacting with something that seemed to be giving us back useful, genuinely human type speech, words, images, now video. Just to very specifically say, this is based on deep learning, which is a software model architecture based on neural networks. It was developed in the 1990s. It's really been rocketed by the developments of data and compute. And again, just to get definitional about it, large language models and ChatGPT are an example of generative AI, which is where the machines are creating new content based on data and patterns that they've been exposed to. But it's not the only form of AI. There are what are called discriminative AI, which is where you're asking the machine learning to classify, is this something like thing X or thing Y? There's lots of applications of narrow AI. So in short, if I was to look a little bit at the future, which is where Sankar was pointing, where's all of this going? First of all, there will be more exciting breakthroughs associated with large language models. I think particularly interesting to look at coupling those capabilities with the sorts of reasoning and sort of strategic approaches of reinforcement learning. But I think just the other sort of strategic sort of exciting development to watch out for is what else might come from different areas of AI. So I think I would summarize by saying this is a genuinely exciting moment, and maybe pointing us in the direction of the next remarks. All that's the sort of theoretical setting, but what really matters is how can it be used? And there's a whole lot of really interesting aspects, many of which Lewis touched on in his remarks, about how, this technology is all very well and good, but how can it actually be used for practical reasons and for good? So with that, I'll hand back to Sankar.
Over to the next question. Here and now, Benson, tell us what AI is doing in Hong Kong for the people.
Well, I'll give you an example of discriminative AI in Hong Kong, noise recognition. Most people in Hong Kong live in multi-story buildings, and renovation noise is indeed a large problem. According to a public survey, renovation noise is the most annoying noise problem in Hong Kong. We do have legislation on general construction noise, but not for renovation noise. We are considering covering renovation noise in the ordinance. So we are developing an AI mobile app because we anticipate one of the most challenging or challenge is that it is in many situations we cannot assess the renovation facts. We cannot get inside. We do not know what exactly what type of equipment are involved in the renovation, because we would like to control some specific type of equipment, like large handheld breakers, for example. So the complainants, we do not know whether such equipment is involved. But with that AI mobile app, they can measure noise outside the renovation flat, and the AI could tell them how likely the large handheld breaker is involved. Do they need to report that case to us for follow-up actions? And without this AI, I think the enforcement of such legislation cannot be proceeded.
Absolutely. Yeah, Hong Kong is not only world's smart city, but we are also making it a livable city. And I hope I'll be forgiven if I say that Arup is taking a key role in developing this AI model for Hong Kong. Magnus, I'm going to pass it back to you. Would you like to share something that is here and now that makes a positive impact?
Yeah, thank you absolutely, and thank you for having me this morning, and for everybody's comments. I'll start just by kind of going back on something that Kara said in her intro, and Lewis said in his presentation about, really when you get down to it, what we're doing with AI is about trying to make the right decisions at the right time. That came from Lewis and from Caro in a landscape we've just got increasing complexity all the time, as with decentralized renewable energy systems. So a lot of our AI right now is focused on just making each of those decision points that we face faster, more accurate, make them learning where traditionally they haven't been. So things like that we have right now is a really beautifully architected, not by me, I must add, national demand forecast model to forecast how much energy the Great Britain will demand per half hour using quite advanced transformer technology. It really is generative AI, and it is a confluence of generative AI and traditional AI. And that model is proving to be something around about 60% more accurate 1 hour out from real time than the one that we're using today. So the potential of that model to massively impact the security, but also the cost of balancing the electricity system is absolutely monumental. And we're just kind of rushing that out to get that into production. But perhaps maybe more relevant to the topic around the built area, one of the things that I'm really excited about is with our new role that Caro referred to, one of the things that we're doing is around regional planning. What do we need to build, and where do we need to build it as we move into the future? Funnily enough, everybody wants electricity on tap, but nobody wants high voltage pylons going through their community. So one of the things that we're doing right now is using LLM technology in order to shorten the gap between communities and community consultation and the planners. A process that probably traditionally would have taken weeks or months if it really happened at all, if the community consultation actually made it to the planning table. Whereas now we're able to take advantage of these new tools to in a very real way connect those two activities. So it's, as Jane said, it's incredibly exciting. It's an incredibly exciting time to be playing with this technology.
Fantastic example. Jean, if I may just change the question for you, because you're from Turing Institute, where does actually the domain expertise play the role in AI? Is it all about the software engineers, or where is the domain expertise coming on play?
Thank you, Sankar. Really important point. I'm going to be provocative and say that a lot of the data science and AI is eminently doable. It's the domain understanding that makes the difference between a kind of nice idea and a deployed functioning product. I love the examples already referred to. And I would probably, I'll just put, so for example, the noise disruption detection, and particularly using it to make that real and sort of monitor and make it real, not just that change for people in Hong Kong. That's a really lovely example. And the national grid balancing is immensely strategically valuable. So in short, I'm not going to say technology is commonplace. It's hard and it has to be done in the right way, and you need the right skills and the right understanding, but it's the domain expertise. What are the interesting problems? And when we start to build the models, how do we understand why they're not working or what surprising result is? And I'll add one more thing. Bringing the people who are going to operate the model, deploy it, use it in practice is absolutely critical. And I will just give one practical example, if I may. We've been involved, along with Network Rail and City University, in a digital twin of a bridge in Staffordshire. And in short, I understand that damage, I'm not a structural engineer, a civil engineer, but I understand that detecting structural change has traditionally been done with audio techniques, but it's actually quite hard to detect small-scale, early-stage damage. In short, this bridge, which is is the IB5 Staffordshire Bridge, to be precise. And the thing about it is it's been built from the get-go with sensors inbuilt. And my reason for talking about it, back to your question about what makes the difference, is it only is useful if Network Rail and other infrastructure providers believe this is useful and build the infrastructure accordingly. And so I would just touch on and maybe open the topic that it matters as much to show that the technology is working, but almost more importantly, that Network Rail, the engineers, embrace this and see this as useful, value for money, practical, because otherwise it won't reach scale and won't be adopted. So I would, in response, Sankar, I would say a mistake often made by technologists is to think that the only bit that matters is the algorithms. There's a lot of, you can't find the right problems or solve them effectively or get them adopted if you've not got that domain expertise.
Actually, it's a very good point. You made me think that AI designed by the domain experts and probably developed by good software engineers probably will be a best bet. Lewis, I'm just going to come over to you. Microsoft has always been known to be an enabler, a partner-oriented company. Can you give some example about, obviously the $2 trillion means that you're continuing to learn, continue to do a lot of new things, something that's close to the ground. Would you like to share something?
Yeah, I mean, I think the thing that gets me most after my 25 plus years in IT is that the important tipping point for all this stuff is consumerization. It's when things move away from domain expertise, software engineering stuff into the realms of, can Jeff and Barbara, who work in HR and admin, get benefit from it at the end of the day, right? And you're looking for the tipping point of consumerization. And consumerization is always, there's an enterprise flavor of it, and then there's a public consumer flavor of it. And I think we're at that tipping point in both worlds, really. Microsoft, from our point of view, our tipping point is Copilot technology. We've wrapped large language model capability into M365. So it sits inside Office productivity tool sets, and it's changing the way in which we consume information, or we refactor, we sort of pass over these big corporate sort of data stores. The challenge there goes back to those responsible AI principles. It's helping the humans to understand how to use the tools and how to trust things that comes back. It's why things like citations that come back in responses are really important. You still have to train people to make conscious decisions about, is what the machine's telling me accurate? And and this is the nature of like making sure that humans have some skin in the game and some responsibility of using the technologies. But that mass consumerization of that happens. I mean, the flip side of that then is Apple's event last night. I'm sure you all probably watched it last night. Well, maybe you didn't, but I did. And so iPhone 16 launched last night and iOS 18, right? So now Apple Intelligence is now baked into their product set. And what you're starting to see there, I think, and this is the bit as well that gets me, is this idea, I call it passive AI for benefit and then non-passive. And what I mean by passive AI, it goes back to kind of what you're talking about in Singapore. So things that are beneficial uses of AI that humans don't have to really think about, but they get some benefit from. So like they've got now the AirPods for instance, have got now hearing capability in terms of preventing hearing loss and hearing strain. So they're active and passive hearing, all controlled by AI and algorithms. But you don't have to think about it. You turn it on, and it's just going to, if you wear them, it's just going to help protect your hearing. The Apple Watch they launched yesterday with the N2 chip in it, it tracks trips, slips, and falls. So it's using AI to help get people back. It can detect early AFib if you're having a heart attack, so it can save people's lives. And there's lots of these passive uses of AI that are driven to the consumer. Do you see what I mean? The non-passive ones on the consumer side of things are the ones that we have to think about, though. And that's like Apple Intelligence. They've baked OpenAI stuff into their Apple Intelligence, so that kind of stuff. And it's all wrapped up in their Apple ecosystem with their private secure compute. But then the throwaway comment yesterday was the fact was that, I think it might have been Tim Cook or might have been Craig Federighi said, but of course, you can also then connect it up to other LLMs and other third-party services, which is great because you want agents to be able to talk to agents. The problem with that, again, going back to learning for us and this tipping point, is that who reads the terms and conditions ever on anything they ever sign up to? I bet most people on the call, if I asked you everyone on the call, how many applications have you actually got installed in your iPhone? I doubt anybody could tell me the exact number of apps they've got on their phone at the moment. Do you see what I mean? And this is the thing that we've got to do as humans to be conscious. It's the non-passive uses of AI where we still have some skin in the game to make decisions or understand. That's the bit I think is where the focus is going. And I think that learning curve, you'll see that tipping point from the mass adoption of consumer tech, like iPhones and iOS, and also then the mass adoption of co-pilot type technology like Microsoft provides as well. It's going to raise the bar, I think, in terms of the normality of AI. Does that make sense? And then the choice is best to kind of really supercharge humans' ability to kind of get the best out of it and minimize the negative.
Sure. Thanks, Lewis, for that. That takes us to the probably next question. This may be provocative. It's my turn now. Senior executives love to get the award, for AI, branding, and everything. But when it comes to make decision, people ask for ROI. People ask, like, what if it says something wrong? What is my liability? There's always a bit of fear component and also a guaranteed return component, while at the same time, they want to do innovation. So I just want to put the first question to the government of Hong Kong first. What is the encouragement to adopt AI? So let's start with the public sector before we go to the private sector. What kind of encouragement do we do to adopt and try a new type of technologies and AI?
Well, I think the most important thing is to cultivate an innovative culture within the organization. We, send people to trainings, and we start with some small projects involving innovative technologies like AI. We start to have some quick wins or get into some local or international competitions, and let these projects visible to the senior management. Let them know their toolbox there, AI and other innovative technologies, and they're more receptive to such innovative technology. And also the legislator, sometimes the external driven, they demand sometimes AI as a solution of older problems.
Yeah.
So.
Yeah. I mean, there was another department in government who said, like, they have 19 divisions of AI teams who compete with each other to get the best. So it's actually really growing fast. But I would like to bring that question to Magnus and Jean and Lewis. Would you like to take that to see how your corporate is actually handling the AI innovation? Fear, returns, or a bit more bravado?
You'd like me to? I'll go. Look, I think one of the for the electricity system operator and soon to be the national energy system operator, it's really not a question of choice. We've got so much complexity coming down, coming towards us due to, as I said before, the decentralized, implementation of renewable technology. That level of complexity, just we would need to scale up the workforce at a unsustainable rate if we were going to try and meet that challenge without using AI. So the bigger challenge isn't about whether we're going to do it. I think the two challenges are first of all, what are we going to do? Because absolutely everybody, everywhere that I speak to agrees that we need to transform, we need to be better, we need to modernize. But when you get to the conversation, what exactly are we going to do and how are you going to transform your area of the business? It becomes a little bit stilted. And I think sort of, taking AI as a very broad definition, going back to the early part of my career when it was, definitely just machine learning, I think ideation has always been a problem, and that gap between the domain and the data scientists. The last point, I'll just quickly make a point. I think one of the things that has changed is traditionally data scientists have been given a very long leash to go and run experiments without a lot of governance around them. And I think we're moving away from that now to being a much more directed process where the end user is, very clear about what it is that they're going to do if the solution is delivered. That the value to the organization of doing that is also covered, is also considered before you start running the experiments, and for that matter, the carbon intensity of it, because then the solution architects need to be able to sit down and go, are we able to generate the power that the end user requires within the economic constraint that the budget requires, with the data that's available? Is this feasible or not? So that you can make a very fast, move fast, fail fast decision. So I think it's all going to be a lot more It's going to maybe a little less fun for some people, but it's going to be a much clearer journey through the end-to-end life cycle, and I think with a much less failure rate than we've traditionally seen, which has been a big problem. I think 80 or 90% of machine learning projects fail to deliver business value. So really trying to head that off, as well as being more considerate of the amount of compute power that we're using in the process, and therefore the carbon intensity.
I've been told that there are plenty of questions, and so before I pass it to Carol, Jean, would you like to give a quick answer to that? From
I would just say that was a brilliant.
What would be a recommendation?
I'm tempted to say very quickly, it has to prove the ROI, because that is how it will be adopted, but also it has to be trusted and it has to be deployed. And as the National Institute for Data Science and AI, we care about all of those things. And rather than sort of speak at length about those, very happy to pick up. But as you say, there are some interesting questions coming in, so I will let you drive where we go next.
Carol, over to you.
Great, thank you. And I think Magnus and Jean's comments on a kind of move to a practical delivery world and also user centricity focus is something that are incredibly close to my heart, and I also think lead to our kind of first question that I'm going to ask that has come from the audience. So what is missing from your sectors or country to really realize the full potential of AI, and how do you see the role of AI evolving over the next decade? I'm going to suggest potentially we go one person from Hong Kong and come in one person from the UK so that we can also cover the remaining questions. Thanks.
Okay, since it's quiet, maybe I just pass it to UK first. Anybody? Any volunteers?
Oh, so I mean, look, I would say, in terms of what is missing, I don't think that it's anything specific to the UK. I think that what we're missing is probably what everyone is missing, which is just an overall, in the interest of time, I'll just call it overall data maturity. And closing that gap between the end user and the data scientists to speed up adoption, as well as speeding and it really is adoption, as Jean said. We can develop as many projects as we like. If it's not actually operationalized by the end user, we haven't moved the needle. Which how do I see the role of AI evolving? I see that changing. And I see LLMs and generative AI being absolutely key to this, to making the algorithms that are being developed accessible and interrogatable by non-technical end users, so that they're able to get information that they need in order to transform their business unit. So I think that access to Gen AI is probably what's been missing in the last sort of 10 or 15 years, and that's what is just, we're right on the cusp of that changing.
Agree, and I think it's going to really help change areas of businesses that previously wouldn't have had access to the kind of transformational impact. Is there anything we want to say from over in Hong Kong, or should we move into the next question?
Well, I think the challenge is to right now is for the user have the knowledge and experience to communicate with the developers of AI, didn't know the limitations or what the decision making were able to explain the decision making process of AI to the public.
Totally, I agree with Benson. It's also the margin of error and the expectation of AI can do 100% magic. That won't happen for some time.
Agree, and I think there's a question of whether or not it should do. So if we go into our second question, so construction, a sector that builds our built environment, is unfortunately known for its poor safety and poor mental health of its workers. Do we have any suggestions of how AI can be used to improve this, or are you aware of any efforts involving AI on this?
Shall I come in?
Yeah, please go ahead, Jean.
Thank you. So super swiftly, I am aware of some very nice computer vision work, which is monitoring construction sites and identifying potential risk areas. I'm not close enough to it to know how mature that is, but I think there are startups operating in this area and it sounds like a really good use case. So that's sort of on the physical, practical side of safety. I didn't know, but I'm concerned to hear that there's a particular mental health issue in the construction sector. I would say we're doing some work with, particularly with the construction sector, about adoption of AI. I don't know whether this is or is not part of it, but I do know, just from general awareness, that actually AI can, because it's good at spotting patterns in data, it is actually making material contributions on mental health. So I won't say more than I don't know of any specific examples of application, but spotting patterns and observing correlations which might flag risk is something that basically machine learning is very good at, and so potentially there could be applications.
That's a good point. I mean, I think from Microsoft's point of view, we've got things like there's obviously been over the years development of augmented reality technology. So we've got our HoloLens platform, which is much more an industrial one. It's used in building environments for health and safety all the time, that kind of thing. I think the problem with those kind of devices at the moment, though, is they're still very expensive. But I feel that what you start to see is the combination of AI to the software development platforms that build the AR capabilities. So like in our kind of low code environment, we call the Power Platform, which is designed for normal users to build applications, but you can do that now just by a prompt. You can write the sentence to say, I would like an augmented reality app to do this for me. But because it's platform enabled all the capabilities, the ability to create applications is now much more democratic. And I thought you also start to see the advent of the shift in consumerization of the technology themselves. So you might have seen Meta's glasses with Ray-Ban, the Meta glasses, which are kind of, when they initially launched those, the little cameras on there were basically used mainly for taking photographs or videos to put up onto Reels on Instagram and Facebook. That was the use case. But that's rapidly shifted now because of Llama and the OpenLM. The real key thing now is the fact they've got integrated headphones in them. Because now you can click a button and say, Meta, what am I looking at? And it's going to basically interpret from the camera, the vision recognition, and use the AI in the background to tell you what you're looking at. Now that's been done in a £300 pair of glasses, which can have lenses. So you can imagine that consumerization of driving down the cost. The application of that at scale for the construction, the built environment becomes a much more useful thing, because it's actually it's the interpretation of the image to data sets in the back end, and just putting that back into ears, sound for humans, is going to have a benefit from health and safety, well-being, that kind of stuff as well. So that's the kind of shift I think you see, increasing sort of consumerization and a combination of audio and visual, I think, in terms of doing stuff, rather than it being one big all-in-one wearable computer. The components break apart and become useful for people.
Great, thank you. And very quickly before we close out, we have a final question, which is how can we strike a balance between the benefits of using AI versus the energy cost of running AI? Should there be a limit to how AI be used to prevent wasting compute power? And I'd love to hear very quickly from both Lewis and Magnus, and then we'll close out.
Yeah, I mean, it's the perennial problem at the moment in terms of that. It's that challenge of having enough energy to run the computer in the first place. I think from our side of the table, there's huge amounts of innovation that go on into the environment itself. So into the built environment itself, but also working with supply chain around the actual things that run, the models run. So the models themselves are software, but they run on physical hardware. So there's a huge amount of innovation that goes in there. So you're going to start to see more innovation around microfluidics, which is basically putting fluid channels onto the actual dies of the chips themselves. So to reduce evaporation, use less water, different die cast techniques, that kind of thing. The challenge there is always going to be this idea of optimizing the models. I mean, remember, AI isn't really the challenge. It's data is almost a bigger challenge than the AI itself, because we're just creating so much stuff all the time. And the efficiency and effectiveness of that combination of the physical hardware with the actual AI models, making sure that they're tuned, they're smaller, they're more efficient to run, and then helping customers to use those in the most cost-constrained physical, it's taking the concept of FinOps, so a financial operations point of view for the business, and wrapping it into what we call SustainOps. So going back to the business unit and say, this is the financial cost of running your applications and your AI in the cloud for you as you as customer service or business. And also that's the sustainability impact of running those services at the moment, and helping them to make conscious decisions about the adoption of new ones as part of a collective inside of a business in terms of power and energy and, you know, water usage and sustainability. Because I think if you gamify it at a board level, then you have a challenge to do that kind of stuff then.
Great, thank you. And I'm sorry, Magnus, but we are now at time. So I'm going to just say a humongous thank you to our speakers, our panelists, as well as everyone who attended for the insightful and thoughtful comments and questions today. I'd also really like to thank Arup's global marketing team for making today happen so seamlessly. I think, you know, honestly, I really believe that today has helped drive the conversation forwards, and I would really like to encourage everyone to keep talking, making connections, and using today as an opportunity to think about, you know, what you can do to help realize the value of AI in the sector that you work in. Before we go completely, I'd also like to re-highlight our other events happening this week as part of Digital Horizons. So tomorrow, our event at 3 p.m. UTC is covering how is digital helping deliver a net zero, climate resilient and nature positive world. And then the day after, how are digital twins and digital asset management accelerating decarbonisation, which is happening at 2 times with 2 different sets of speakers at 8 a.m. UTC and 3 p.m. UTC. Huge thank you again to absolutely everyone who's made today happen, and have a lovely rest of your day, afternoon or evening, depending on where you are in the world. Thank you.
Thank you.
Thank you.
Sure.